Hi guys, I am going to go through Investigation 4, Part 1 with you. We're actually going to do Step 1 about the phenolphthalein as a demo, and I'm going to do that for you right now, so you'll be able to record this data before you even come to class. I'm just a little bit concerned with time next class, and so I figure if we can take care of this on the video, then that's one less thing you're going to have to do in class and possibly run short, especially because I think we're going to have class meetings in this class period as well. So I'm reading out of the lab manual, and you'll be able to have all of your pre-lab stuff done, so you'll be able to read out of your lab notebook. But it says place some phenolphthalein in 2 tubes. That's what I've got going on here. Add 0.1 molar HCl to 1 tube, swirl to mix and observe. Using the same procedure, add 0.1 molar NaOH to the other tube. Repeat the procedure and observe or make your observations. So I have my phenolphthalein in each tube. This one got a little bit cloudy when I put the phenolphthalein in there, probably because there was something in that tube before I put it in there. That's okay. It's not that big of a deal. I have my 0.1 molar NaOH that I'm going to put into one of the tubes. But instead of using 0.1 molar hydrochloric acid, we're actually going to use distilled white vinegar. And because the reason we're going to use this instead is because you're going to use this for the second step with your cells here shortly. So we're going to be consistent with our items, I guess you can call. It says on here 0.5 or 5% acidity. So if you didn't know, vinegar is actually acetic acid, and it's a nice dilute, weak acid that we can use in class in place of other acids that are maybe a little bit more dangerous. I like to use household products whenever I can. So I'm going to start by putting a little bit of my base in one test tube, and we get bright pink. Perfect. And I'm going to put some of my vinegar. I put some of my vinegar in a cup before I started videoing, and we get nothing. This is perfect. This is exactly what we expect. Phenolphthalein is an acid-base indicator. I'm sure you remember that from chemistry. And what happens is when we mix it with a base, we get a very bright pink color. When we mix it with an acid, we get no color change at all. It remains clear. And that's exactly what you're seeing here. And that matters for part 2. So now we know what's our acid and what's our base, and what the color change indicates. So then when you get to step 2, it says, use a dull knife or a thin strip of hard plastic to cut 3 blocks of agar of different sizes. Well, your strip of plastic is this. This is a piece of a plastic dinner plate that I cut into something with sharp edges. And I'm going to give you a piece of agar. Agar is like gelatin, like Jell-O, only not sweet and delicious. But I made it pink, okay? And the way I made it pink was by adding phenolphthalein and a weak base before it solidified, so when I was making it out of the liquid, and now it's bright pink. And so what you're going to do is cut 3 cells out of the chunk I give you, and I'm not going to give you a giant chunk, but this is plenty. And I want you to just use your red knife-ish thing to cut 3 cells as cube as possible. If they're not perfect cubes, that's okay, because you'll measure length, width, and height for each cube. But you want 1 large cell, 1 medium cell, and 1 small cell in order for you to calculate your rate of diffusion. And this cuts beautifully, just like this. And so cut, like I said, as cubed as possible. Okay, you want even edges. And then you're going to cut a medium-sized cell, and then you're also going to cut a small cell. And so when you do this, I'm cutting large, medium, and small, getting rid of my excess. And then in order to make them cubes, you just use your knife again from the other direction, okay, making them as cube-like as possible. So here, there's something that's, it's not a perfect cube. It's more rectangular than anything else, but that's what you're shooting for. That's a good small size. And then you have medium size, slightly larger, and then largest, of course, you're going to leave it as it is, as big as you can. You will have recorded your sizes in your data table. If you have an edge, mine's off of the edge, you can see that it's kind of, I don't know, a lighter pink. If you want to cut that off when you're making your cubes, that'll work out as well. So you just chop that off. And then we're ready to measure the rate of diffusion into your cells. And the way we're going to do that is by tracking the color change of your pink Jello cells. So you'll get the white cup works the best, and you're putting vinegar in here, so you're going to smell like pickles all day, and that's okay. And then what you do is you put your pink cells, all 3 of them, in your cup at the same time. And what you're going to do is that there's your cells, in 1-minute increments, you're going to pull them back out of the vinegar, and you're going to measure with your ruler the color change. So I'm going to put them in here, and I'm going to pause the video, and I'm going to come back in a couple of minutes, and I'm going to show you the color change that we're seeing and then how you're going to measure that. Okay, so what you're looking at in that cup are my pink cells, and what you can very clearly see is there's a white band that's coming in from the outside of the agar, that's the gelatin-like stuff, and that white band is how far the acid, or your vinegar, has diffused into your cell. Now, as soon as I pull those cells out of the cup, it's going to stop diffusing, right? So I have to collect data in 1-minute increments. And so what you'll want to do is put the cells in the agar, time it for a minute, then pull all 3 of them out, dry them off on a paper towel. That will stop the reaction from occurring. Collect your data, put them all back in for 1 minute, take them out, dry them off, stops the reaction, collect your data, and so on. You'll do that for 10 minutes. So I'm going to pull one out now, and I'm going to show you what that kind of looks like as far as data collection is involved. So I'm going to pause it for a second, flip my camera around, and then we can keep recording. Okay, so there's my cells. Use a spoon to get them out of the cup, otherwise you're really going to smell like pickles all day. And drain as much of that vinegar in the cup as you can, and then as you pull it out, put it on a paper towel so that you can collect your data without it continuing to react. You can still see pretty nicely the white band. That's how far in diffusion has occurred. And then all you have to do is get your ruler, use centimeters please, because you're in science class, and then you just measure the distance between the outside edge of that agar cube and where the pink begins. Now, depending on your cells, you may not have quite as clear of a line the whole way around. So like, for example, on this edge, it's harder for me to see a clear pink line. And so you only have to take 1 measurement per cell. And so pick a place where it's very easy to see a crisp line between the pink and the clear, and that can be your point of measurement. The only word of caution with this lab, and it's pretty foolproof as far as getting your pink stuff to turn white is concerned, you want to make sure that in your cup while you're waiting, that you're kind of stirring them around, because if your cells get stuck to each other, they're not going to diffuse properly. So your data is going to be really wonky, and that's kind of hard for you to analyze later. So you want to make sure that you're allowing the vinegar to come in contact with all of your cells. Of course, if they are completely clear sooner than 10 minutes, you don't have to continue to collect data at that point. You're finished. But my guess is the largest cell is probably not going to be completely done in 10 minutes. So thanks for watching my video. Thanks for doing your pre-lab, and I'll see you in class.